Tell us a little bit about your neuron model.
So I basically built the neuron like I built the example in the packet, and
Okay, so like for example, could you tell me about some of the structures in the neuron and how they function? And then maybe tell me about why you decided to make your model look the way that it does, or use the materials that you used in your model. So I know one thing I didn't hear Marley talk about was this part of the neuron. So what structure are we looking at right here?
the myelin sheath.
Yeah, so that would be the myelin sheath. And then what's the function of the myelin sheath? Why do we have one in a neuron?
It doesn't say on the book.
Okay.
To keep it's like it acts as an insulator.
Okay.
Unless the electricity doesn't go everywhere. It's like the wire example, where the electricity in the wire, the metal part of the wire won't go anywhere if it'll go everywhere that it touches. So if the rubber acts as the sheath part acts as an insulator to keep the electricity in.
So you're saying that we actually have electricity running through our nerve cells?
Mm-hmm.
Wow.
That's how they.
That's cool. Awesome. And then what is the myelin sheath covering in the nerve? Like what would this part of the nerve be called?
The node of Rambier.
I do notice that you made something maybe that looks like a node of Rambier. Those look like these little pieces of pipe cleaner with beads on them. Do you know how the nodes of Rambier function?
No, I don't know.
Okay.
I put them on it though. Oh.
It is true. There's a reference right on the board.
Okay.
So.
So it's a gate that stops and allows messages to be transmitted.
Okay. So what's the message where's the message traveling then in the nerve? How does a message go through a nerve? And if you want to, you could point at the screen too. You could kind of explain what's happening in the nerve by pointing at your model.
Okay, so I put the nucleus as a little white bead right there.
Okay.
And then.
So how does the message get to the nucleus, maybe?
It goes through the dendrites.
Okay.
And goes through there and up to the axon terminals.
So the dendrites bring the message to the nucleus of the cell?
I think so. Yeah.
And then the nucleus is in the soma of the cell. I heard Marley talk about that.
The dendrites receive messages and bring them back, send them to the cell body.
Okay. And then from the cell body, what happens?
We go to the axon.
Okay, so they travel down the axon.
And go to the axon terminal.
Okay, and now we're at the axon terminals. So what happens at the axon terminals?
They attach onto other dendrites and send a message along.
Yeah, and actually, so I would say a lot of the time cells are attached to each other. Nerve cells aren't attached to each other, but they're very close to each other. So what's going to happen at these terminals is that if the electrical charge travels down the axon, it's going to cause different chemicals to be released by the terminals at these things, which are going to be called synaptic bulbs. Neurotransmitters are the chemicals that are released, and then if the neurotransmitters go from the synaptic bulbs of this cell to the dendritic bulbs on the other side of the synapse in the other cell, then that message can travel down to the cell body, and that whole process can happen again. So sometimes it takes more than one nerve for an impulse to travel. Sometimes neurons are really long. Like for example, in your arms and legs, you can have a neuron that's maybe 2 or 3 feet long. There's going to be a lot of neurons that are bundled together into something called a nerve. And you can send a message down a long neuron pretty quickly. In your brain, you might have a lot of different neurons working together. Cool.